Hello, welcome to 3.3.3. In today's video, we're just going to be talking about applying the product and the quotient rules in a more abstract manner. The AP exam is notorious for testing your knowledge of rules, such as a product rule and quotient rule, but doing it in novel and new ways. So it's important to expose you to different ways of seeing these rules to make sure that you really have the rule down and you can answer the questions when they pop up. I normally start this class with a quick activity asking people to actually write out the product rule and the quotient rule from memory. I would encourage you to pause the video and do this on your own to make sure you have those rules memorized. It's going to be imperative that you know these rules backwards and forwards, that you got to memorize without a problem. These should be like super well memorized, right? All right, so product rule. Product rule is first times derivative of the second plus second times derivative of the first. So if I've got f times g there and I'm taking the derivative of that product, it would be first times the derivative of the second plus second times derivative of the first. F times g prime plus g times f prime. Quotient rule. The mnemonic device for that was low d high minus high d low all over low squared. So low d high would be g f prime minus high d low would be f g prime all over low squared. Don't forget that bottom part. A lot of times people forget to put it all over low squared. So it's going to be g times f prime minus f times g prime all over g squared. Know those rules. All right. Today's video is just about applying those rules. But before we do, a quick couple of things. So be aware that sometimes when you have a quotient, you can actually find the derivative without the quotient rule. Sometimes you need the quotient rule, like sometimes it's unavoidable. For this one, I'm going to do it both ways just to kind of exemplify that fact. So for this one, I'm going to use a quotient rule to find y prime. Quotient rule is low d high, so low is x cubed. Derivative of high, so derivative of 5 is just 0 because 5 is a constant, minus high d low, 5. Derivative of low would be 3x squared, right? Bringing a 3 down, dropping the power by 1, all over low squared, x cubed squared. If I simplify this out a bit, x cubed times 0 is gone. That's just 0. So I'll have negative 15x squared all over x to the 6th. Can do a little bit of simplifying there. That'll be negative 15 all over x to the 4th. Quotient rule. There's my answer. However, if I were actually doing this problem, I probably wouldn't use quotient rule in this particular case. And that's because I know my powers of my exponential rules really well. I know if I've got something like 5 over x to the 3rd, I can rewrite that as 5 times x to the negative 3rd, right? These are equivalent, remembering your rules for negative exponents. And if I write it like this, all of a sudden it's not a quotient anymore. So I don't need the quotient rule for this one. I could just bring that 3 down and use my standard shortcuts. Negative 3 times 5 is negative 15. X, drop the power by 1, so instead of x to the negative 3, x to the negative 4th. This answer, and the answer I came up with before, same exact answer. All right, so just one thing to be aware of, quotient rule is awesome. I use it all the time, and so a lot of times it's the only way to use it, but I don't use it just because I see a quotient. Sometimes we could rewrite it and make it quicker and faster. All right, let's get to the main stuff for today. So AP Calc problem is going to test your knowledge of quotient rules and product rules, possibly by giving you something like this, right? It's going to give you a bunch of different values, and then it's going to say, hey, find the derivative of u over v at x equals 2. Well, you'll notice all of these things were evaluated at 2. There's u evaluated at 2, u prime evaluated at 2, v evaluated at 2, v prime evaluated at 2. Basically, it gave me all the information I need. Even if I don't know exactly what u and what v are, that's fine, because I can still find the derivative. I know that this derivative can be found using the quotient rule. Low d high, so low is v, d high, u prime, minus high d low, u, times v prime, all over low squared, v squared. And they gave me all the things I needed. V at 2, well, that's just right here. At 2, v is equal to 1. U prime at 2, that's just here. U prime at 2 is -4, and I can just plug in the things I need. So the derivative at 2, even though I don't know what the functions are, I can find the derivative at 2 because I'm given all of this information. In this case, let's see here, v we said would be 1. U prime, that's over here, that's -4. Minus u, that's over here, u of 2 is 3. V prime, that's over here, that's 2. All over v squared, that's right there, 1. So that's -4 minus 6 more is -10 all over 1, which is just -10. Just like that. Same thing for the product rule, right? Oops. I know product rule is first times the derivative of the second plus second times the derivative of the first. So then just plug in your values. U is at 2 is 3. V prime at 2 is 2. V at 2 is 1. And U prime at 2 is -4. So that'd be 6 minus 4, which is 2. All there is to it. All right. A problem like this can throw people off because it seems easier. Just be careful that we understand what u and v are. U and v are not variables. I'm not asking you to find the derivative of 2x plus 9x, right? U and v are some equations that I don't know what they are. Like u might be x squared plus 3, and v might be 14x to the 7th. Like I just don't know what equations they are, right? So I can't treat these like variables. They're not variables. But I can still apply my rules, right? So my rules say if I'm taking the derivative of 2 times something, that's the exact same thing as just taking 2 times the derivative of that something, right? Plus, that's 9 times something. If I want the derivative of 9 times something, that's the exact same thing as taking 9 times the derivative of that something. So this derivative of 2u plus 9v would be 2u prime plus 9v prime. That's my sum and difference rule, right? U prime I know. U prime at 2 is -4, so 2 times -4 plus 9. V prime is right there. V prime of 2 is 2. That's -8 plus 18, that's 10. All right, so just testing out your knowledge of derivative rules. All right, the last type of one is word problems. Again, this one kind of goes to the point of remembering what a derivative measures. A derivative measures rate of change or slope. So let's read through this problem. It says a rectangle currently has a length of 7 meters and a width of 3 centimeters. Length is increasing by 2 centimeters per minute. Width is increasing by 4 centimeters per minute. At what rate is the area of the rectangle changing? All right, so it's basically saying I've got this rectangle. It's currently a 7 by 3 centimeter rectangle, but it's growing, right? This width is growing at a rate of, or that length is growing at a rate of 2 centimeters per minute. So this is my length, but my rate of change in length, my dl dx, how quickly that length is changing, that's 2. I'm increasing at 2 centimeters per second. The width is also increasing. It's increasing at 4 centimeters per minute, not per second. So this w, that's 3 centimeters, I know how fast the w is changing, dw dx. That's changing at 4 centimeters per second. Right? This is centimeters per minute. I keep saying per second. That's centimeters per minute. Right? And so the question is saying, well, at what rate is the area of the rectangle changing? Since this width is growing and this length is growing and width is growing, that area is also growing. The question is at what rate? So I'm measuring area. Formula for area is just length times width. If I want the rate of change of the area, that's A prime. That's a derivative of A. So A prime is equal to, and so that's a product. It's going to require the product rule. First times the derivative of the second times W prime plus second times the derivative of the first. Well, L stands for length. That's 7. Times W prime stands for the rate of change of W. That's right here, dW dx. That's W prime, how quickly it's changing. That's a 4. Plus W, that's a width, right here is 3. Times L prime is how fast the length is changing. That's dL dx. How fast is that L changing? That is 2. That's 28 plus 6. 28 plus 6 is 34. So it's changing at a rate of 34. It's got a unit here. Centimeters squared per minute. Let's talk about that label for a minute. Without doing much work, I knew it was centimeters squared per minute because it's a measure of area. And if this is measured in centimeters and that's measured in centimeters, area would be centimeters squared. That's where this came from. And per minute, because these rates of change were per minute, so that area is going to be per minute. But you don't have to actually just rely on your intuition to actually get that right. The labels actually work out for this. If I had labeled these correctly, that 7 isn't just a 7 by itself, it's 7 centimeters. That 4 is right here. That was 4 centimeters per minute. And the same thing for the 3 and the 2. That was 3 centimeters. And 2 centimeters per minute. And if I multiply that out, that's 4 times 7 is 28. Centimeters times centimeters is centimeters squared per minute. Plus 3 times 2 is 6. Centimeters times centimeters is centimeters squared per minute. 34 centimeters squared per minute. Right? Labels work out just fine. All right, one last problem, and then we're done for today. This one's not area, so it's a math that we may not be quite as familiar with. It says Sarah has 100 shares of stock that is currently valued at $15 per share. Her employer is giving her more stock at a rate of $8 per share, or sorry, 8 shares per year. Meanwhile, the value of each share is increasing at a rate of 125 per year. What is the current rate of change of the value of her stock assets? And I had a hint here that I was going to pull out, but I can't pull it out, so I'm just going to write it down. Since this is what I'm trying to find, the rate of change of that, I need a formula that gives her the value of her stock assets. So the value, well, the value is going to depend on 2 things. How many shares of stock she has and what the price per share is, right? So the value is going to equal the number of her number of shares times the price per share of the stock. Price per share. Right? It'd be nice if we had some variables for this. So let's have V stand for value, maybe N for numbers, and P be price per share. Right? I'm looking for the rate of change of that value, so I need to find the derivative. I need to find V prime. Well, that's a product. So V prime would be N times P prime plus P times N prime. Remembering, of course, that N was equal to the number of shares and P was equal to the price per share. All right. I want to know the current rate of change. So I want to know what is that rate of change right now? What is V prime right now? So that's going to depend on what N is right now. Well, N is the number of shares she has right now. Currently, she has 100 shares. P prime is how quickly the price per share is changing, right? P is the price per share. So P prime would be how much that's increasing, changing. It's right here. It's increasing by $1.25 per year. So $1.25. plus P stands for the price per share. The price per share is currently at 15 per share. It's $15 times N prime. Well, N prime is how quickly N is changing. N is a number of shares, so N prime would be how quickly that's changing. Right here, her employer is giving her more stock at a rate of 8 per share. So that's increasing by 8 per year. Plug those numbers in. $1.25 times 100 is 125. 15 times 8, let's see here, that'd be 120. So this is changing at a rate of $245. This is actually dollars per year. It's per year because of two reasons. Again, intuitively, all these measurements were being measured in per year. That's $1.25 per year. That's 8 shares per year. And then I could also have borne it out with the labels, but I never bothered to put the labels for these. That 100 should have been labeled 100 shares. This $1.25 should actually have been $1.25 per year per share, right? So that, I mean, the labels work out just fine. But yeah, end up being $245 per year. That's the current rate of change in her values, in the value of her stock assets. I'm not sure how much it's worth right now. You could figure that out easy enough. Right now she has 100 shares valued at $15 per share. 100 times 15, that's $1,500, which isn't huge, but rate of change of $245 per year, that means next year it's going to be $1,745, and then probably increase even more after that. It's not a lot now, but that's going to grow pretty well. All right, that's it. Give the assignment a try. There's just 4 problems. 2 of them kind of like these ones up here, and 2 of them more like word problems. To help you out with the word problem ones, I got a couple of hints down there. Wait for my computer to get caught up. There it goes. Got a couple of hints. Annual production is number of trees times yield per tree. Members' share of a fee is a total cost divided by the number of members. Give those ones a shot, and I will see you guys next time.